Okay, today we're going to go ahead and we're going to talk about Chapter 1. Chapter 1 is Equations of Lines. And this is review. This is something we've done multiple times in Algebra 1, Geometry, and Algebra 2. And now we're reviewing it again in pre-calculus. It's the foundational things that you have to be able to understand to be able to move on in pre-calculus. So the first thing we need to talk about is slope. The Webster's Dictionary definition of slope is steepness of a line. The graphical definition is going to be the rise or the change in your y over the run, which is the change in your x. However, the algebraic definition, given x1, y1, and x2, y2, the formula to find the slope is going to be y2 minus y1 over x2 minus x1. Now, the important one that I want to talk about is this right here. This is always read from left to right, and if you ever had me in Algebra 2, you have seen this picture multiple times. And basically, you're reading this from left to right, and there are 4 lines. The first line is going up the mountain, the second line is going down the mountain, and the third one is level, and the fourth one is the cliff. So if you are going up the mountain, your slope is positive. If you're going down the mountain, your slope is negative. If you are on level ground, it's 0. And if you're looking over the railing of a cliff, it is undetermined what is down there, so our slope is undefined. Now, if there is an equation that falls on the mountain, the equation is in the form of mx plus b. So if you fall on the mountain, your equation has both x and y in it. If you fall on level ground, that's going to be y equals a number, and if you fall on the cliff, that's going to be x equals a number. Always and forever. You get so much information from just looking at that right there. Okay, so let's apply this information. So if we're applying this, I'm going to give you 2 points, 2, 1, and 2, -5, and I want you to find the slope and then the equation of this line. So most of you are immediately going to go ahead and say x1, y1, x2, y2, and you are going to write the slope formula. And you're going to have -5 minus 1 over 2 minus 2, which gives you -6 over 0. And then your brain's going to stutter a minute, and you're going to say, oh, is 0 in the top allowed or not? Well, if you have 0 in the bottom, it's sad, and if you have 0 on the top, it's happy, meaning good versus evil, however you want to think. What I want your brain to understand, if 0 is in the top, it's 0. If 0 is in the bottom, it's undefined. Our 0 is in the bottom, so that implies that our slope is undefined. So if our slope is undefined, then what we learned right here is that it's x equals a number because it's undefined. Well, if that's a true statement, x equals a number, well, what number does x equal? Well, if you look at your ordered pairs, x is 2 in both of those ordered pairs, which has, x has no choice but to be the value 2. So if you would have looked at this more closely instead of jumping straight into the algebraic definition, you would have seen that the x values were both the same, so implying that x has to be 2, which implies this is a vertical line, and vertical lines have no slope, meaning undefined. So look for those shortcuts because that's what your brain needs to be doing now in pre-calculus. So here's the next example, 4, -3, and 6, -3. Now, your brain should be looking for those shortcuts, and it should say, oh, well, I guess that means that -3 and -3 is the same value for y, so that means y must be -3. Well, that is a true statement, which means your slope is going to be 0 because that is on level ground. When it's y equals a number, that means your slope is 0. This is where your pre-calculus brain should go. Some of you are still in your geometry brain, and you're going to be saying, okay, -3 minus -3 over 6 minus 4, 0 over 2, 0 on the top is allowed, so 0 is my slope, and then you're going to try to find the equation of the line. You should not have to do any of this. You should be able to go straight to y equals -3. So that is the quick shortcut way. So, same exact thing, but this time I give you 2 points, -2, 0, and 3, 1, and guess what? There's no shortcut here. You have no choice but to go straight to the labeling and then straight to the plug and chug. So that's 1 minus 0 over 3 minus negative 2. So that's 1 over, double negative's a positive, 1/5. Okay? So now we've talked about slope, we've talked about the equations of lines whenever it comes to having the same x's or the same y's. Now let's physically find all the equations of the lines. So how do we go about that? There are two methods. The first method is going to be the slope-intercept form, which is y equals mx plus b, and you always and forever will label your point xy. M is your slope and b is your y-intercept. Your y-intercept is a point. It is 0b. Super important your brain understands that. I am very picky about a y-intercept. A y-intercept is a point on the graph, so therefore it must have an x-coordinate and a y-coordinate. Point slope form is going to be the other formula that you can use, and that's y minus y1 equals m times x minus x1. When you utilize this, you always will use the point x1, y1. You will keep the first x and the first y, and everything else is subbed in, and then you will solve for y, and you will get your answer. Now, we're going to do this problem right here using both methods. Okay, we're going to do both of them. As you can tell in these two next examples, they're exactly the same, 100% the same problem. But the first one says to do it in the slope-intercept formula, which means you are using y equals mx plus b, which means you are labeling your point x and y. So y is negative 5, m is negative 3, x is 2 plus b. So negative 5 is equal to negative 6 plus b. Add the 6, and you have 1 is equal to b. Now, that means my equation, my answer, is y is equal to negative 3x plus 1. So, after we found b, we had to plug it back in with our slope to be able to come up with the equation. Now, over here on the next example, we're going to use this formula, y minus y1 is equal to m times x minus x1. And we're going to utilize the point x1, y1, and that's what we're going to be labeling that point as. And we're going to simply keep the first y and the first x that you see. So that's y minus a negative 5 is equal to equal to negative 3 times x minus a 2. And we are simply going to solve this thing for y. So a double negative is a positive. Distribute the negative 3 to give you negative 3x plus 6. And simply solve for y by subtracting 5. Y is equal to negative 3x plus 1. And we're done. I like the second method, which is the point slope method, better than I like slope-intercept formula, for the simple fact that I plug in once, I solve for y, and I am done. Both methods will work, and it's not a big deal which one you choose. Now, with that being said, the next problem, instead of giving you a point and a slope, I'm now giving you 2 points. So immediately, your brain should be looking for those shortcuts. Are my x's the same? Nope. Are my y's the same? Nope. So what am I forced to do? Well, I have to find the equation of the line, which means in order to find the equation of the line, I must have a point and a slope. Currently, I have 2 points. So what I'm going to do is I'm going to calculate the slope. So that's 8 minus negative 2 over negative 3 minus negative 5. 8 plus 2 gives me a 10. Double negative creates a positive, so my slope is going to be 5. So if my slope is 5, I now need to choose a point. And I always choose the point with fewer negatives. And then I'm going to plug and chug into my formula. And again, I said I kind of have a preference for using the second formula. Again, that's totally up to you if you want to use y equals mx plus b. Keeping in mind the first y, that was meant to be a highlighter, y'all. The first y and the first x are going to stay in the problem, and then you are going to simply plug and chug everything else. So y minus 8 is equal to a 5 times an x minus a negative 3. A double negative creates a positive. Y minus 8 is equal to 5x plus 15. Add the 8, and we get y is equal to 5x plus 23. So, as you can see, we get y equals 5x plus 23. Now remember, with this problem, the biggest key was you first found the slope and then chose one of the given points and plugged and chugged into the formula. Okay, so we've talked about a whole bunch of our lines. We've discovered how to be able to find the equation of a line. Now we need to talk about actually finding parallel and perpendicular lines. So how do we go about that? Parallel lines, folks, I need your brain to think train tracks. So if you're thinking train tracks, that means that your slopes of those two lines are exactly the same slope. Meaning, if I ask for my parallel slope, whenever it's 1/2, then it has to be 1/2, right? Because they're parallel, they're the same. Perpendicular lines, the symbol is an upside down T, is going to be the opposite or the negative reciprocal. So if it was positive, it's now negative. If it was negative, it's now positive. So if I want the perpendicular slope of this, perpendicular means it was positive, so it's now negative. The reciprocal of 1/2 is now 2. So my perpendicular slope is -2. So let's keep going with this. M equals -5. What is the parallel slope? -5. What is the perpendicular slope? It now goes from negative to positive. The reciprocal of 5 is 1/5. How about the slope of -2/3? Parallel is the same. Perpendicular is opposite, making it positive. Reciprocal, making it 3/2. Parallel to 4/5 is going to be 4/5. Perpendicular, opposite's negative. Reciprocal is going to be 5/4. Super important your brain grasp that. Because now I'm going to say we have the exact same problem. The given information is exactly the same on the next two examples. What's different is the first one is asking for the parallel line, and the second one is asking for the perpendicular line. But the process is exactly the same. What do I mean? So if we take the first one, what we're going to do is we're going to take the given equation, which is 2x minus 3y is equal to 5. And we're going to solve that for y. And the reason why we're solving that for y is because I need the slope out of that equation. I'm going to divide each and every term by -3. So I have y is equal to positive 2/3 x minus 5/3. Now remember, I said I wanted to find the slope out of that equation. So the slope of this line is 2/3. Okay, well that's super important because now I want to know what the parallel slope is. Parallel means the same, so I have 2/3. And don't forget, I'm now going to use the point that they gave me, 2, -1. Okay, let's switch gears. Perpendicular line. Well, if my parallel slope is 2/3, what is my perpendicular slope? Well, my perpendicular slope is going to be the opposite of positive, which makes that negative, and the reciprocal of 2/3 makes that 3/2. And we're still going to use the same point, which is 2, -1. So, now that we have all that information, let's go ahead and actually find the equation. So I have y equals mx plus b. Haven't used that one for a while, so we're going to. This is x, this is y. Y is -1, m is going to be 2/3, x is going to be 2 plus b. So -1 is equal to 4/3 plus b. Now, the little trick here is to multiply the entire equation by my denominator to eliminate that fraction. -3 equals 4 plus 3b. So if I subtract 4, that gives me -7 is equal to 3b. So -7/3 is equal to b. Now remember, I said when we use this formula, we are not done. We have to make sure that we finish and plug and chug. So our parallel line is going to be y is equal to my parallel slope, which is 2/3 x, plus my b value, which is -7/3. That is my parallel line. So we're going to do the same exact thing with this. Now we're going to go ahead and do perpendicular. We already have the perpendicular slope. We're going to use our formula. So y is equal to mx plus b. Y is -1, m is -3/2, x is 2 plus b. How nice, the 2's cancel out. -1 is equal to -3 plus b. Add the 3. And write the right number. 2 is equal to b. So my equation, my perpendicular line, is going to be y is equal to -3/2x plus 2. So parallel and perpendicular are both done. You can see that the slopes are opposite reciprocals, which they should be. And another nice check is if you're doing the parallel, the slopes are the same. And if you're doing the perpendicular, the slopes are opposite reciprocals, which is extremely important. Last problem of the day for your notes. This is a really easy one that oftentimes you never get in Algebra 2. So find the parallel line through 3x minus 5 equals 10. Okay, great. So 3x, let's go ahead and solve this. So 3x is equal to 15. So x is equal to 3. An alarm should be sounding really loudly in your head. You should be seeing this mountain picture in your head, and you should say, where is x equals a number? X equals a number is going to be right here, which means this is a vertical line. Correct? If it's a vertical line, what is parallel to a vertical line is another vertical line. So it has to be x equals. Whenever I say parallel, your brain needs to think same. Same means the same letter too. So it has to look like this. So you're simply going to go look at your ordered pair and you're going to pull out the x coordinate of your ordered pair. So that means x is equal to -1. Now, many of you are like, how did she get that? Where did that come from? Well, that came from if you were to go ahead and graph this, because sometimes we need a visual. If we were to graph x equals 3, there it is. If we were to graph the ordered pair -1, 4, -1, 4 puts me right here. And guess what? What is parallel to a vertical line is another vertical line. So therefore, that has to be x equals -1. I wrote 1 there, and I should have written 3. Okay? So you can see it visibly also whenever I graph it, how that all comes to play. An alarm should be sounding immediately whenever you're like, there's no y. So if there's no y, how do I find the equation of the line? And this is it, right there. Parallel, same letter. If it was perpendicular, you would use the opposite letter, and you would have y equals. And it would be y equals 4 if it was perpendicular. Okay, I am going to stop with the recording. I'm going to start your homework here in a second.